Okay, at this time, we're going to begin our lesson on writing log equations. Now, keep in mind that the majority of this lesson is done without the use of a calculator, okay? Nonetheless, you can still use it, but we're trying to prepare you guys for the college algebra course, the pre-calculus course, and so on. So, let's go ahead and look at the first question, which is to identify the domain, range, and vertical asymptote for each of the following log equations below. Now, first, let's go ahead and begin with the domain. How do I identify the domain? Well, I will always go ahead and use the terms within the parentheses of the logarithm. In this case scenario, I have x minus 1, and I set this to be greater than 0. My logarithm is always strictly positive, okay? So based on that information, I will then add 1 on both sides. Plus 1, plus 1. This will now leave us with x is greater than positive 1. And this will represent the inequality notation of the domain. So on the right-hand side, I want you to write down domain. And we're going to write down all three different notations. First, let's begin with the inequality notation, which is given to us by x is greater than positive 1. We will then write down the interval notation, which is given to us by parentheses 1 is all the way to positive infinity. That's our domain. And we also have the set builder notation or the set notation. Here we go. So we have an open brace in which we have for all x's, keep in mind that this is a vertical bar. This is not a 1, it's a vertical bar. Okay, so for all x's in which x is greater than 1. So these are the three different formats for writing down the domain. From there, we will then talk about the range. Okay, so for the range, write this down with me, we have three different notations. But if you recall from our lesson yesterday, we mentioned that the range for all log functions will be from negative infinity to positive infinity. So down below, we're going to write down that the range is going to be from negative infinity to positive infinity. This is the interval notation. We also have the set notation down below. So we have for all y's in which y is going to be an element of the real number set. Okay, so it can be any number, a decimal, a fraction, any number, okay? We also have the verbal description for the range, which is given to us for all real numbers. Let's write that down. All real numbers. Finally, we're going to identify the vertical asymptote, okay? So how do I identify the vertical asymptote? Well, it's pretty much the same idea as finding the domain. We take the terms within the parentheses and we set them equal to 0. So I have x minus 1 is equal to 0. Not greater than 0, equal to 0. From there, I do my basic algebra 1 to isolate for x. So I add 1 on both sides. This will now leave me with x is equal to positive 1. Hence, the vertical asymptote is going to be located at x equals 1. Keep in mind that a vertical asymptote, or an asymptote for that matter, is an imaginary line that we cannot intercept. We get very close to it, we approach it, but we never intercept it. You're going to hear more about that in calculus for the limits. Okay? So on the left hand, actually on the very top, let's go ahead and write down VA for shorthand notation of vertical asymptote. And we're going to write down that it's going to be x equals positive 1. From there, let's go ahead and move on to our second example. We have y equals negative log of x plus 3. Now, keep in mind that if we don't have a base, it's known to be what, guys? What's the base if it's not written down? It's a 10. Good. Awesome. Now, what is this logarithm referred to? It's a very unique name, right? If we have a log of base 10, what is that called? It's a common log. Good. Awesome. Now, the reason why I'm emphasizing this is because perhaps there might be a multiple choice question that will say you have a common log, and you have to know that it has to have a base of 10. Okay? From there, we will then take the terms inside the parentheses. Let's say we want to identify the domain first. Okay? So we take the terms inside the parentheses. We just have x. So we have what? X is greater than 0. Did I get x to be all by itself? Yes, I did. Luckily, this one was done for us, okay? So what do we do now? Well, we write down the domain. And we're going to write down the 3 different notations. You never know which one you're going to see on the exam. You need to be prepped for all 3. So let's write down the inequality notation first. We have x is greater than 0. That's the inequality notation. We also have the interval notation, which is given to us as the following. From 0 all the way to positive infinity. We also have the set notation, which is given to us in the following format. We have a brace, and it's going to be for all x's in which x is going to be greater than 0. That's the set notation. Then we have our range. Let's go ahead and write that down. We have our range. And keep in mind that the range of all logarithms is going to be from negative infinity to positive infinity. So let's write that down. So we're going to begin with the interval notation, which is given to us by negative infinity to positive infinity. We're then going to write down the set notation, which is given to us by the following. For all y's in which y is going to be an element of the real number set. We also have the verbal description, correct? We have all real numbers. Okay? Finally, we then have the vertical asymptote. Keep in mind that the vertical asymptote is derived in the same format as you found domain, which is by doing what? We take the terms within the parentheses and we set them equal to 0, and we isolate for x. If you look at this one right here, we have x equals 0, so x is already all by itself. So we have found the vertical asymptote, okay? So let's go ahead and label that. The VA for shorthand notation is going to be x equals 0. And look at that, guys. We were able to identify the domain, the range, the vertical asymptote without the use of a calculator, okay? So keep in mind, yes, there are tougher questions in the pre-calc class, in the college algebra class, but for the most part, they should be at this level where you can do this mentally in your head, okay? Questions, doubts about this? All right, let's go ahead and move on to the next part. So down below, we're going from an equation to a description. So look at the instructions right here. We have to describe the transformations from the parent function. So watch what I do right here, guys. Watch this. We have y equals log of x minus 4 plus 3. My first step is to label the h value. So this negative 4 is going to be my h value. If I have a minus 4 or a number inside the parentheses next to the x, then that will be what? A horizontal translation, either going to the left or going to the right. In this case scenario, because I have a minus 4, it's going to go to the right 4 units. Let's write that down. So y was translated right 4 units. Aha, right? Really easy, yes? Now, keep in mind that the majority of the exam, right, for the free response is made up of the transformations, as you guys may know for the previous exams, okay? So then we go to our k value. So this number that's outside, if it's a plus, it's going to go vertically upwards. If it's a negative, the graph will go vertically downwards, correct? So write down comma and up 3 units. Now keep in mind that the description can become a little bit more fancy, right? I can definitely say y was horizontally translated right 4 units and vertically up 3 units. That could potentially be another description that you might see on the multiple choice of the test. or perhaps that you can write down for the free response. Okay? Now, let's move on to the next example right here. So for this one, notice that we have what? Y equals negative 3 log base 2 of x plus 1 minus 4. Notice that we have a negative 3 for the A value. Keep in mind that if we have a negative symbol, it's going to be a reflection across the x-axis, right? And if we have a number that's greater than 1, it's going to be a vertical stretch, okay? But if the number is between 0 and 1, okay, it's going to be a vertical compression, all right? So let's go ahead and write that down. So we have y was reflected across, or over, that's actually nicer, over the x-axis, comma, vertically stretched. You can also say expanded, your choice, by 3, or by a factor of 3, comma, and now we move on to the h value. Marina, can we see this from back there? Yes? Okay, awesome. All right, and then we have our h value, that's a plus 1, correct? So if it's a plus, it's going to go to the left. So let's write that down. So translated, you have to mention that vocab word, okay? Translated, or you can say shifted, correct? So translated left 1 unit, comma, and now we look at the k value. The k value is what? Negative 4. So that's going to be what? Vertically down by 4 units, correct? So let's write that down. And down 4 units. Aha, look at that, guys. So again, you're going to see this for the free response. Victor, you're going to see this for the free response. It shouldn't be blank. You need to know how to do this, guys. Every single exam that we have had since the start of the second semester has had transformations, okay? All right, let's move on to a tougher question. Here we go in 3, in 2, in 1. All right, so for this one, we have y equals 1/4 natural log, okay? Remember, if you see an ln, that's a natural log with a natural base of e. X minus 1 plus 3. So for this one, notice that I have a fraction between 0 and 1 for the a value. So this will be a vertical compression. Let's write that down. Y was vertically compressed by 1/4 okay, comma, and then we have what? Our negative 1 for the h value. So that means what? We're going to go to the right by 1 unit, correct? So write down comma, translated right 1 unit, comma, and then we have a k value of positive 3. So it's going to go up by 3. And up 3 units. There we go. Aha, super easy, right? Hopefully you're looking at this and you're thinking, Mr. Alvarez, this is so easy, I can do this in my sleep. Which is good, right? Even Aiden's doing it in his sleep, right? I mean, look at him, he's sleeping right now. All right, anyway, let's go ahead and move on to the next one. Here we go. For the next one, we have y equals 3 times log base 2 of x plus 6 minus 4. So for this one, we have an a value of 3. Let's write that down. So this is going to be a vertical stretch or a vertical expansion. Let's write that down. Y was vertically stretched by 3. You can also say by a factor of 3, okay? Comma, then we notice that we have an h value of positive 6. Let's write that down. So if it's a plus, it's going to go to the left. So write down translated left 6 units, comma, and then we have a minus 4, so that's our k value. So it's going to go down by 4, So write down and down 4 units. Questions, doubts about this so far? We're good? All right. Now, finally, again, you're going to see this on the free response. All right, so down below, we're going from a description to an equation. So down below, look right here, guys. It says, write the log equation that matches the transformations. So keep in mind that if we're doing this, it has to be in the following format. Write this down with me, guys, okay? We have y equals a log base b of x minus h, close parentheses, plus k. That's the format that you should give for the written equation. Questions? Okay, now let's go ahead and break down the first example. This is going to look very similar to your free response portion of the test. Okay, it says a log function with a base of 10. Okay, so let's write this down. We have a log function with a base of 10. So write down b equals 10. That is reflected over the x-axis. So what does this mean, guys? It means that the a value has to be a negative, right? It has to have a negative symbol. So write down a equals negative. That is shifted 6 units to the right. Okay, so this is going to be my h value. So we have what? So if it's going to the right-hand side, it's going to be a minus 6, correct? So write down h equals negative 6. Then it says what? Down 3 units. This is going to be for my k value, okay? And it's going to be what? K equals negative 3 because it's going to go down by 3. So if I put all of this together, I have y equals log, I have the negative symbol. Don't forget about that, guys. We had a negative symbol right there. Y equals negative log base 10 of parentheses x minus 6, close parentheses, and then minus 3. And guess what? That is going to be our final solution. Let's go ahead and box that up. There we go. Questions, doubts about this, guys? Now, let's finish the last one. Okay, perfect. Yeah, go ahead. All right, so now, do I need to write down this base of 10, guys? Did I need to do that? No. So just keep that in mind. If you don't want to write down the base of 10, if you do have that, you will still get full marks on the free response. But anything else, if it's a base of 7, base of 8, who knows, you do need to write it down. It's only for the base of 10 that you don't have to write down. Okay? Nonetheless, let's go ahead and move on to the next question. Now, this one's unique. Look right here, guys. This one is going to be for a natural log function. So go ahead and underline that right there. So if you ever see that, it has to be with the ln. Write that down, ln. Okay? Then it says what? It's vertically expanded by a factor of 3. So that's going to be what? A equals 3. Write that down. Then it says shifted to the left by 2 units. So that means what? H equals plus 2, right? In order to go to the left, it needs to be a plus. And finally, it says what? Up 1 unit. So you have k equals plus 1, correct? It will go vertically upwards. So if I put all of this together, I have y equals natural log. Oh, we forgot something. We forgot to write down the 3 in the very front, right? The expansion, right? The vertical is stretched. So we have 3 times natural log. Now, keep in mind that the natural log always has a base of e. We do not need to write down the base of this one. It's already known to be an e, correct? Don't write it down. Just leave it alone. All right, then we are told what? Parentheses shifted to the left, so it's going to be what? X plus 2. And finally, we have a vertical shift going up by 1, so plus 1 outside the parentheses. And look at that. We have arrived at our final solution. Let's go ahead and box that up. There we go. Okay, so now, based on what we have done, guys, okay, based on what we have done, what did we learn today? So, when your mom, your dad, grandma, grandpa, uncle, aunt picks you up and they say, Little Arisha, what did you learn today? Well, little Arisha is going to go ahead and say, I learned about identifying the domain, the range, the vertical asymptote without the use of the calculator. Yes, I'm that smart, without the calculator. And she will also say what? That she knows how to convert from a log equation to the verbal description and from a description to an equation. Okay, she's that smart. Okay, awesome. So let me just stop.